Okay, number 4b, we're still evaluating the definite integral. Remember, the only way that we have to evaluate a definite integral right now is by finding area. So we need to be able to find the area using a graph, which means that we have to graph this. So a couple things to notice that might be a little bit different than the functions that you've graphed so far is that this y-intercept is high. And then our slope is up 1 over 1, because remember, we are always looking for y equals mx plus b form. The b is the y-intercept, which in this case is positive 8. The slope is in front of x. If it's a whole number like this one, then it's always over 1. So we're rise over 1, up 1 over 1. The other thing is that these limits are relatively big. Usually we're only going from like -1 to 2, like the last one, or -2 to 1. But this is -6 to 8. So we're going to need a rather large graph for this. So just heads up if you're writing this on your paper. So I'm going to write this. So my x-axis, we don't end up going below the x-axis. So we're going to have -1, -2, -3, -4, -5, -6. We know we'll have to at least go to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And we'll have to go up to 8. So that's my y-intercept, this 8, and then the other 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's positive 8 there. So to draw this line, I'm going to start at 8. And I have to go all the way over to 8. So I'm going to go up 1 over 1. So it's 9, 1. Up 1 over 1, 10, 2. 11 is 3. Oh, this is going to go pretty high. 12 is here. So 12 is 4. 13 is 5. 14 is 6. I have to move this down again. A little bit easier for me than it is for you. Oops. Okay, move this back up here. Okay. And so we are at, what are we at? This is 1, 2, 3, 4, 5, 6. We need 7 and 8, so 7. So this is 8, 9, 10, 11, 12, 13, 14, 15, and 16. So all the way up here is 16 and 8. So there's my line. And if you want to move backwards, if you're going up and to the right, to keep with this, you can move both of them backwards, which would be down and to the left. So down and to the left, 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 down to the left, and one more down to the left. So this is 1, 2, 3, 4, 5, 6, 7, there's 8. So this is at -1, -2, -3, -4, -5, -6. And that's at 2. So there it is. So we are looking from here to here. Huge graph. Okay. So if we look at this graph, the shapes that you're going to have to recognize are triangles, rectangles, circles, and trapezoids. If we look at this shape, this is kind of a huge and elongated trapezoid. We have two sides that are not of equal length. They're connected by a diagonal and they have a flat bottom. So that is one kind of trapezoid. So remember, to find the area of a trapezoid is 1/2 height, which in this case is the bottom length, base 1 plus base 2. So 1/2, the height is from -6 to +8. So we'll have 6 here plus 8, so that's a total of 14 in the middle there. And base 1 and base 2 are the y values of our end points. So our end point is -6 here, and our y value is +2. Our end point is 8 here, and our y value, if we go back up to what we counted out up here, is 16. So when we add this, 1/2 of 14 is 7, 2 plus 16 is 18, and 7 times is 126. All of this is above the x-axis, so the answer to my definite integral is 126.